This is problem 21 of chapter 19. So we've been given some information about some history of vitamin D and its relationship to this disease called Rickets in England. There's some concern that these days people or children that watch a lot of TV and play with computer games are not getting outside, getting sunlight, and producing vitamin D. So that makes them more susceptible to rickets. So that's the concern. And we have a sample where we have a sample size of 2,700, and of that sample, 20% are deficient in vitamin D. Okay, so what we are being asked is to produce a 90% confidence interval to estimate the true proportion of children in England that are deficient in vitamin D. Okay, so before we do this, we need to check to make sure it's valid to do so. So we need to check some conditions. So the plausible independence condition, this is where we sort of kind of just justify that these children are independent with respect to vitamin D. So we could say something to that effect. It is reasonable to think that randomly selected children are mutually independent in regards to vitamin D deficiency, something to that effect. Okay, the random condition. I think they said it was random. There it is. So we don't have to justify that the sample is representative. We just need to say yes, they selected children randomly. Okay, the 10% condition, well, 270 is less than, 10% of all children in England. I think that makes sense. It's a small island compared to the United States, but still it's got a few people on it. Let's see, the success-failure condition. So that we want to check if n times p hat is greater than or equal to 20. So that's 270 times 0.2. Okay, and then we want to check that n times q hat is greater than or equal to 10, and so that's 270 greater than or equal, 270 times, sorry, I was trying to do the math in my head, 0.80. Okay, so I'm pretty sure this is 2 times, that's 540. Can't write today. Okay, and then let's see, 8, I should be able to do this. 8 times 6, 5, 16, so 16, 20, I think, right? Yeah, I'm pretty sure that's true. Okay, definitely bigger than independent of my math, they're both greater than 10, and that's the most important thing. So therefore, the sample size is large enough. I could do this. Okay, so I just need to add some zeros. So, okay, so let's see. We need a transition statement. So the conditions, whoa, what happened? Conditions are satisfied. So we can use a one proportion z interval to estimate the proportion of children in England that are vitamin vitamin D deficient. Okay, so that's what we're going to do. So let's see. So we need an estimate plus or minus a margin of error. So the estimate is p hat plus or minus z star times the square root of p hat q hat all divided by n, square root of that. So this is 0.20 plus or minus z star. We'll come back to that in a minute. 0.20 times 0.8 divided by 270. Now, z star is a function of the confidence interval, and here they want us to find a 98% confidence interval, so that's not a typical one. So let's see if we can just figure this out real quickly. Let's draw a normal distribution best we can. So this is 98% of the area right here. That's a 9, trust me. So this would be 0.01 and this would be 0.01. So z star is equal to inverse norm of 0.01. And you find that by doing, you go second distribution and you go down to number 3, select it, 0.01, and you get 2.326. So 2.236. We're actually further out than we normally are. And so if you do this computation, you get a confidence interval. So you might, get used to doing this with the calculator, but your confidence interval should be 18.2% to 21.8%. Okay? So the next part, we would want to interpret the confidence interval. So we would say that we are 98% confident that between 18.2% and 21.8% of English children. How about children in England? I don't know if they're English or not, are deficient in vitamin, can't spell vitamin, D. Okay? That's how you interpret the confidence interval. It's always required at the end of a computation. And then they say explain what 98% means in this case. So there's a couple ways of saying it, but this time I'm going to say that if we produced 100 unique samples of size 270, we would expect 98 of them to capture the true proportion of children in England that are deficient in vitamin D. Okay? So there's other ways of saying that. You could say 98% of all confidence intervals of this same size will capture the true proportion of children in England that are vitamin D deficient. But this sometimes is easier to say because you take out the percent stuff and just say if we did this 100 times with 100 unique samples, 98% of them, we'd expect 98% of them to capture the true proportion. Okay, so there's another example for you. You can see these are long and drawn out primarily because it takes time to check the conditions. Okay, good luck.